diagnosing these always gets a little bit tricky. This one doesn't have a factorial in it. I feel like the factorial is a dead giveaway. But I do see that I can't, it's not geometric. It's not a power series situation. I can't, this piece really throws me off in terms of trying to create a geometric situation with the powers that I see, with the exponentials that I see. But because it's so messy, it's almost a giveaway that it has to be a ratio test. It takes a little practice to see that, but remember, exponentials and factorials, and then anything that you can't easily see as geometric is definitely going to be a ratio test. So we'll immediately set up the limit. And we're going to do n plus 1. So n plus 1, let's see if I can get all that, squared. And then this is going to be 3 to the n plus 1. I'm replacing n plus 1 everywhere I see an n. Okay, plus 1. So obviously I'm going to simplify that to n plus 2 in just a second. And this is going to be 2 to the n plus 1. Everywhere you see an n, you are replacing that with an n plus 1. Then the bottom, the comparison piece, is n squared times 3 to the n plus 1 over 2n. So now it's up to us to get rid of the complex fraction and see if we can simplify anything. Limit as n approaches infinity. Obviously, I'm going to simplify that to n plus 2 just to help me out a little bit. But I've got n plus 1 all squared. And that's going to be divided by, remember you're multiplying these pieces together and these pieces together. And that's going to be divided by just n squared. I try to line mine up where I can see what may have the potential to reduce and what doesn't. Then you're going to have 2 to the n over 2 to the n plus 1. And you can put it all in one fraction if you want to. I just like separating mine so I can see it a little better. And then you're going to have 3 to the n plus 2 over 3 to the n plus 1. So that's what we're trying to simplify. So let's take another look at this and see what we see here. Looking at that, you've got more 2's in the bottom, right? So I'm going to end up with an extra 2 in the bottom. Here, you've got more 3's in the top. Whenever you compare those, you can subtract those exponents if you want to, but you're going to end up with this limit. I don't know why my screen keeps zooming in like that. Limit as n approaches infinity. I've got n plus 1 squared over n squared times 3 is the leftover over 2. Okay, well that 3 halves is just a coefficient. I can move that out to the front, and now I'm just evaluating the limit as n approaches infinity of n plus 1 squared over n squared. That's what I'm looking for. Now that is absolute value situation, but because they're both squared, I don't have to have the absolute value signs. So as n goes to infinity, yes, technically you're dealing with infinity over infinity, but if you look at that closer, you could look at that as spit in the ocean, right? N squared plus 2n plus 1 over n squared. There's your spit in the ocean. So as n goes to infinity, that whole limit, okay, is going to be 1. So you end up with 3 halves times 1, which is 3 halves, and you're comparing that to 1. Oh, it's not less than. So that's greater than 1, which means that the series diverges by ratio test.